And welcome everybody to another fun edition of Subnet Saturday. It is great to be with you. If you're just joining us for the first time, oh my gosh, so good to have you here. My name is Keith Barker. I have been double CCNA. Got my first one in 2001, which is a long time ago. I got my second one in 2003, and I've continued to enjoy learning new things and rehearsing my skills with Cisco. And I want to pass those on to you as part of these live streams and this content regarding CCNA. So if you are brand new to the channel, I look forward to seeing you in future videos and live streams. And if you haven't already, go ahead and click on the subscribe button, click on the alert button so you can be alerted when there's new videos that are coming up. All right, so if you're just joining us for the first time, on Saturdays, we do some content on subnets and subnetting for IPv4. And I think we've had like 10 previous to this point. So if you're new to subnetting, new to IP addressing, no problem whatsoever. Super glad that you are here. And what I'd encourage you to do is schedule some time, go back to the Keith Barker channel here on YouTube, and then there's a separate playlist just for Subnet Saturdays. It starts at 1, 2, 3, and goes through. And it'll take you step by step through the world of IP addressing, so you can not only understand how it works, you can also become very, very good and competent at carving out subnets, identifying what subnet a client lives on, all of which are important skills in the modern day of networking with IPv4. So this is episode 11 for Subnet Saturdays, and here's what I thought would be fun to do. Getting hands-on practice with doing subnetting is important, and Packet Tracer is free from Cisco. So to get Packet Tracer, it's a simulator that lets you just a ton of practice, especially at the CCNA level, lots of practice on virtually everything there. You can download it from netacad.com. netacad.com, sign up for a free account. Nope, doesn't cost anything. You can download Packet Tracer. The version I'm using is 7.3, I believe. I'll take a look at that when we get into it. And I built this lab as part of an opportunity to have a coworker, you probably know him, Network Chuck, who I built this lab, and he's going to inject some problems into it for me. And then what I'll do is I'll do a live presentation where I haven't looked at it yet, and we can walk through the actual problem solving and problem resolution and T-shooting with that lab. So I thought, you know what, let's take this lab that I built and let me walk through with you how I went through the subnetting for it, and that'll give you hands-on practice. If you want to replicate this, you're welcome to. Also, I have made this file available, the one that I'm actually going to be working from. I built it on Monday. I'll put it up on my site so you can download it, and I'll show you how to do that as well. So if you download Packet Tracer, which is free, you can download this lab that I created, which is free from my site, and then you can follow right along with subnetting. And again, if you haven't yet learned about IP addressing or subnetting or custom subnetting or variable length subnet masking, I would encourage you to check out that playlist at Keith Barker's website, my site, and get up to speed. It won't take very long. You can get right up to speed. Also, there's a full playlist for CCNA content right there as well. I say full. I call it the master playlist, but when I do these recordings and streams, I put them all on a playlist so they're easy to find. So before we're done today, I'll show you, make sure you're clear on where you can go for all that and download it for free and get to work. All right, let's look at our topology, and then let's look at our plan for variable length subnet masking. And let me bring up the web camera over here on this machine as well and get my pen ready. All right, my pen is ready. So here's what I did, a little background just briefly on this topology that I built. I thought, how do I integrate all these different technologies so that Network Chuck can take this and break one or two or more parts of it, save it, and then give it back to me, and then we can do a live troubleshooting. By the way, I think it's a great idea. I'm super excited to see what troubles he injects into the lab. Anyway, the basics of it is this, is that I've got the access layer. Now the access layer is the logical layer or the representation of where customers connect in. So printers and PCs and devices, like if you see a cube, if they're wired in, there's going to be a little connection in their office they use to connect into the wiring closet to a switch that goes down to the distribution block down probably in the basement of the data center. And this is the access layer. So on the access layer, the technologies involved there would be VLANs. So I created several VLANs, including VLAN 10, 20, I have VLAN 7, VLAN 30, and so forth. So I had created those VLANs, and they also had to be created on these multi-layer switches. Now, multi-layer switch, as you probably already know, if you've enjoyed several of these sessions with me, a multi-layer switch is a device that can do layer 2 forwarding, like a traditional layer 2 switch, and it has the ability to do layer 3 routing using SVIs. all of that content we've covered up to this point in the master playlist. So an SVI is a switched virtual interface, just a logical layer 3 interface that allows these multi-layer switches, MLS 1 and 2, to do routing for each of these subnets and also to provide layer 2 switching respectively as well for the various VLANs. And let's see here. So I've carved out the access ports for this PC. He's in VLAN 20. And I carved out this access port here on this switch. He's in VLAN 10. And then I also set up trunking. So there's trunking, 802.1q trunking, between the access layer switches and the distribution layer or core switches here, MLS 1 for multi-layer switch 1 and multi-layer switch 2. And then on these bad boys, they've also got the SVIs for VLANs 10 and 20, so they can do routing on behalf of those clients. I've also got a DHCP server here that's handing out IP addresses for VLAN 10. There's also a DHCP relay agent sitting in VLAN 10 on the VLAN interface for MLS 1 and 2, which is able, the local server is there on VLAN 10. So over here in VLAN 20, where there is no local DHCP server, I've got on the VLAN 20 interfaces on the multi-layer switches DHCP relay. Everyone, I just realized every one of those topics, if you're new, is like, what? What's that? What's that? What's that? These are all topics that we have 100% covered in the live streams and videos up to this point from the master playlist. So if you haven't yet taken a look at that, here's what I'd strongly recommend you do. Let me go ahead and hide that pen just for a moment. And let me bring up, this is the, let me make sure my video's on. Good. So this is the Keith Barker channel on YouTube. And if you go down, I've organized it and I put my playlist right here up front. Here's the CCNA 200-301 master playlist. And there's also one just for subnetting. So depending on which one you want to focus on. And if you go to the master playlist, let me go ahead and click on view full playlist. Again, this is at the Keith Barker channel on YouTube. And then just take a look. If you're just starting your journey, start at the beginning. Intro to clients, servers, and protocols, layer 2 switching and VLANs. And then even if you have some practice or you have some experience and exposure and you just want to brush up on a couple pieces, just scroll down the playlist. I think there's like 48 plus videos here, and it's growing by the week. So you just scroll down to the parts that may seem interesting to you or you need to brush up on. And port security, here's all these subnet Saturdays. And this episode, I believe it's 11, I'll tuck in there as well. And the cool thing is, this one playlist, if you just go through it, as I add new content, you can just go through and pick the parts that you want. If you're new, I would encourage you to go through all of it. Yeah, I'm daydreaming. Oh, look at that. That looks good. That looks good. Anyway, so Keith Barker's site is where you can get that. Also, for this packet tracer file that I'm working with, that I built on Monday, that Chuck Keith is going to troubleshoot for me, I should say Network Chuck is going to troubleshoot for me, you can also download that. This is the file that I'm going to be sharing with you today as far as the pieces and parts. You can go to the site called thekeithbarker.com. thekeithbarker.com. And if you can click on downloads here at thekeithbarker.com, or if you scroll down, there's a subscribe option for YouTube, which you probably already subscribed, or I hope you have. And then right here, the Cisco PT IPv4 subnets, if you click on that link, it will download this packet tracer lab that I'm sharing with you right now. So if you want to download it and open it up with packet tracer and just as we go through the subnetting, verify what's where, or any of the other technologies, that'd be great. So feel free. Also, for wireless local area network and packet tracer, there's a link here on the left. There's one for IPv6. We did IPv6 routing session. That file is here. And now this one is Cisco packet tracer for IPv4 subnets. All right. Having said that, let's go back to our topology. Let me bring back my pen. And let's talk about the rest of this real quick. So actually, I have a separate stream that's going to talk more detail about this topology, but just as a quick refresher or a quick add-on, R1 here has a switch module, and so it has a VLAN interface that allows it to have trunking and access to the multi-layer switches. And as far as the network addressing, I've got over here on the right, it goes off to the WAN network with site 1 and site 2. And I've carved out, let me clear this off, I carved out the IP addressing requirements. And I did this backwards. I built the topology first, and then I realized, I should have probably planned out the IP addressing. And then I had to step back, go back and say, okay, now what do I want to do for IP addressing? So if we had 3 sites, so we have headquarters here, and then site 1 and site 2, we could take an address like this, 10.67.83.0, and maybe we've been told that we need to make our entire infrastructure, or at least this portion of our network, fit into this address space of 10.67.83.0. And if we have 3 sites, we can say, okay, great, we have the headquarter site, we've got site 1, site 2, and then we would need to decide, okay, how do we want to take this pie, as we talked about in variable length subnet masking, how do we want to break that one network up into multiple subnets? And this is going to rely heavily on the previous videos we've had together regarding subnetting up to this point. So as a starting point, let's do this. For the headquarter site, let's use 10.67.83.0 slash, and let's use a slash 26. And then for site 1, we can use 10.67.83.64 slash 26. And for site 2, 10.67.83.128 slash 26. And so and again, it took a little bit of thought to get to that point. I was thinking, how many addresses do I need here, and so forth. And here's the plan I made for the headquarters site right here. The plan I made was that I want to have a VLAN, and I just put the numbers in after the fact. You can call a VLAN whatever number you want. But I decided that VLAN 10, I'd need 14 hosts. And that for VLAN 20, I want 14 hosts. Now that 14 hosts means 14 IP addresses that we can use on those networks. And that also is going to get back to how many bits are we leaving for host bits on each of those segments, as we're doing. Basically, we're going to take this block of addresses right here, and we're going to do variable length subnet masking to create the appropriate subnets out of that space slash 26, because the 64 network and the 128 networks are going to be for site 1 and 2 respectively. So we need to carve, if we can, if there's enough room, we need to carve this out of this address space. So for VLAN 20, for VLAN 10, I need 14 hosts, and for VLAN 20, I need 14 hosts. And then I also have a management VLAN. Now, this is a really important concept. As an administrator, whether we're doing console or whether we're doing SSH access to every single device, let's go to the big screen for a second. Whether we're doing SSH access to our switches and routers, we need to get there. We need to have access there. And if we're going to do it in a more secure way than just using the normal networks, we might want to create a management VLAN. That's a VLAN that's dedicated for just managing our devices. So we could use it as we SSH to those devices, like the access layer switches and the multi-layer switches in our router, or we could use network automation. Maybe we have a controller that's communicating to those network devices, and we want to have a dedicated VLAN just for that management traffic and that control traffic. So that's what a management VLAN is good for, is that we don't have to use the same VLANs that our users are on. We can have a separate VLAN just for the management team, meaning the devices who want to be managed on that network, and keep it separate from their other traffic. So to do that, I thought to myself, okay, well, how do we do that? We have several devices. I've got, in this switched environment here, I've got access 1, it's an access layer switch, and I've got access 2, and I've got this multi-layer switch, and this second multi-layer switch, and this router that has a switch module in it, and so it has VLAN access as well. We could create one logical VLAN, and I would need to support 1, 2, 3, 4, 5, and I think I gave myself one more as a safety net. I wanted to create a management VLAN that supported at least 6 devices or 6 IP addresses, so that I could have a separate management network just for access layer switches, multi-layer switches, and this router in the same management network. So I said, well, as part of my plan, I'll call that VLAN 7, and let's go ahead and make sure we have at least 6 host address, or 6 available host addressing for 6 devices on that management network. And then for down here, for the router going out to the WAN sites for its like site 1 and site 2, I needed, let me back up. I got excited about WAN. Let's talk about VLAN 30. There's also a logical VLAN that I want to use, and I'll put that in a separate color here. Right here between R1, MLS1, and MLS2. And that is it only needs to support 3 devices, because I want to have this multi-layer switch and this multi-layer switch and this router on its VLAN interface all on VLAN 30. I want them to peer with each other so they can be OSPF neighbors, and that way if MLS2 dies, I still have access out to the rest of the internet and my network through MLS1, or if MLS1 dies, I still have access through MLS2, or if there's another basically I want some fault tolerance regarding my connectivity if either one of these switches died. So to do that, I created a separate network, a separate VLAN that MLS1, MLS2, and this router could all communicate on. And all I need is 3 hosts, 3 IP addresses for those 3 devices. So the VLANs would look something like this. I'd have VLAN 10. Again, a slightly different color here. I'd have VLAN 20. Oh, you know, if I was being really clever, I could color them the same color as these are. That's all right. VLAN 10, VLAN 20, and then VLAN 30 here, and then the management VLAN, which I will put in, let's go ahead and put them in maybe purpley. That's kind of purple. That's the management VLAN right there. And that is going to be VLAN 7, which I can then access layer switch 1 to MLS1, MLS2, or the headquarters router, all on that VLAN for management, like SSH sessions or network automation and sessions to those devices using that dedicated VLAN. And they all have access to it, so I need those addresses. And then for the WAN network, I need 3 addresses. And that's because I have 3 routers, R1, R2, and R3. So again, it's like, Keith, that's a lot of data. Yeah, that's a lot of data. But my purpose in this Subnet Saturday was to impress upon you that we can use a topology like this, and you can download this right now, if you'd like, from the keithbarker.com and take a look at it. But the key was how do we, we take this design, and now we understand what we want to do as far as subnetting. How do we carve all those out? And that's what I'd like to walk you through right now, is let's carve out the actual subnets that would support this many hosts for each of those subnets, and then we can actually implement it in Packet Tracer to verify that it works, which is also a key element. Like if you put it in and we enable routing with like OSPF, if it doesn't work, or if you put an IP address in at Bark saying this isn't the invalid whatever, that's really great practice for saying, okay, where did I go wrong? And it's actually the chance to not only design subnetting with VLSM, but also a chance to actually verify that it works. So let me clear off all that chicken scratch. And let's focus on the headquarters site. And for the headquarters site, here's what we're going to do. It's going to be 10.67.83.0/26. And let's go ahead and carve these out. These are, let's see, 14, 14, 6, 3, and 3. Great. So we want to start with bigger hosts, bigger networks, and then work our way down. So if this is our starting point, our first network is going to be 10.67.83.0 because with variable length subnet masking, you start with whatever the current network is, and that's going to be your first subnet simply with a longer mask. Now the key is, and this is a review from a few previous videos that we've had together regarding host bits and VLSM, is if we needed to have 14 hosts, the question that I would ask you is, how many host bits at the end of the IP address do we need to leave for host addressing if we need to support up to 14 hosts? And the answer is the finger game. And my finger is getting a little better. I slammed this in the door about 2 months ago, and it didn't fall off gratefully. But yeah, somebody's asking, what's with the fingernail? It's like, yeah, it just got beat up in a door. Door versus fingernail. Door one, fingernail 0. Okay, so if we want to support at least 14 devices on a subnet, how many bits do we need to leave for host addressing at the end of that IP address that the mask does not take to support 14 hosts? And the answer is you get your thumb in the air. There's a 2 on that thumb. I'm not going to get out a black marker. You've seen me do that before. But our fingers represent bits. On the thumbnail, there's a 2. And we simply bring up another bit and double and double and double until we get to our quantity that we need. So if we need to leave enough bits for 14 hosts, the answer is that's not enough. 2, 4, that's not enough. 8, that's not enough. 16. So, and then we have to subtract 2 because you can't use the all zeros or the all ones. You can't use the network or the broadcast address. So with 4 bits on, we could actually support 14 hosts. 2, 4, 8, 16, minus 2, 14. Yeah. So all we need to do is leave at the end of our IP address 4 host bits available for host addressing, and that'll meet those needs. So let's do that on paper. All right, so back here, what we would do is say, well, we need to leave 4 bits. I'm going to put up my table here I'm going to put it down here at the bottom of 1, 2, 4, 8, 16, 32, 64, 128, and put a period there. This represents the 3rd octet going that way. This is the 4th octet going this way. And I'm just going to do a quick check. 1, 2, 3, 4, 5, 6, 7, 8. Make sure you have 8 bit positions there so the math doesn't go south. And what we need to do is we need to leave 4 bits for host addressing. That means we're going to leave this one, this one, this one, this one. That our mask would be right here. So if we're leaving these 4 bits, our mask would look like this. It'd be 1, 1, 1, 1. And then we're going to leave that bit, leave that bit, leave that bit, leave that bit for host addressing. So our mask, our new mask would be, I'm going to just do the math. I'm going to just count. Start here. It's 24, 25, 26, 27, 28. Our new mask is /28. Ta-da! That's our new mask. So our first network for VLAN 10 would be 10.67.83.0 with a /28. Let's look at my notes to make sure I'm right. Yeah. So that'd be our first network, and so we can see down here that this is network. I'm going to put it over here to the left in a slightly different color. So that'd be, actually, I'll just put an arrow. That'll work. So that's going to be our VLAN 10, and in that network, oh, here we go. This is subnet. I'm going to call it .83.0, and it has a /28, and then we could then put in our IP addresses. So for this subnet right here that we just identified, 10.67.83.0, what is the next subnet? That'll help us figure out our range really, really quickly. When we say, well, Keith, we learned this in the block size videos as part of the Subnet Saturdays. So if we take a look at this /28, the block size is 16. And that would mean that the next subnet would be 10.67.83.16. So I'm going to put next here, next, .16. And that would mean our range for this network would be .1 through .14. And we can't use 0 because that's the actual network ID. And we can't use .15 because that would be the host bits all 1. That's the broadcast address. So there's our range. And then we could make our plan and say, okay, great. This is the 83 subnet. The multilayer switch 1, its VLAN 10 interface. I want to use the first IP address. So we'd put it in there. I'd say this .1. Multilayer switch 2, its VLAN 10 interface. I want it to be the second IP address in the subnet. .2, are we going to use first hop redundancy protocol? We had a video on that in this playlist. Maybe HSRP or Gateway Load Balancing Protocol or VRRP. And if you're going to use a virtual IP address for FHRP, first hop redundancy protocol, you could go ahead and identify that here. Let's say we want to have it be .3. And because that would need an IP address if we're going to set it up between the 2 multilayer switches. Then R1 down here is not on VLAN 10, so it doesn't need one. The server, so the server is up here in VLAN 10. That's if we carve that port out in VLAN 10. So let me erase that, and I got my eraser. So this is a design decision, really. It's like, what do we want to do? What do we want to do here? Let me look at my notes. This is my okay. Yep. So what I want to do is this. I want to use the server as .3, and I'm only saying I want to because that's the decision I made. The server is at .3, and the FHRP virtual address we're going to put at .4. R1's not on the VLAN 10. This access layer switch certainly is supporting layer 2 services on VLAN 10, but it doesn't have a VLAN interface on VLAN 10. It will on the management VLAN 7. So access layer switch doesn't need an IP address. The client doesn't need an IP address access to. And R2 and R3 on the remote sites, they don't need an IP address here in this VLAN either. Okay, so there's our plan for VLAN 10. Now let's take a look at our next subnet. So our next subnet is going to be, oh, it's right here. So our next subnet is 16. And how many bits do we need to leave for host addressing? 14. So the math is the same, meaning we're going to use the same mask again. Another /28 because we need the same number of hosts. And that's going to be the .16 subnet. I'll put a slash here, 28. And then we could identify what addresses do we want the multilayer switches to have. What do we want MLS1 on its VLAN 20 interface? I'm going to give it the first IP address, which is going to be, the range is going to be .17 through, and if we had 1632, it'd be 17 through 30 for the range. And I'm just going to check my notes here real quick. Yeah. Yeah, I thought since this is being recorded, we want to have accurate data. So if we wanted the multi-layer switches 1 and 2 to have the first and second IP addresses in VLAN 20, we can just go ahead and pick them. So .17, .18, and then for FHRP, for first hop redundancy protocol, if we want to support that for VLAN 20, we need to specify what that is as well. My guess is, so let's go for 19. So I honestly don't remember what I have for the first hop router address for FHRP. Let's go check because I've got the lab. It's running. Let's go check. I'm just going to hide that for a moment. Let's go to Packet Tracer, which is right here. And let's look at the FHRP address for VLAN 20. And we can do this on either switch. So I'm going to go to MLS2 and make sure that I have this in frame so you can see it. Actually, let me go to MLS1. Let me go to multi-layer switch 1. That way we can physically see it on the left and see it here. So here in Packet Tracer. All right, here we go. Go into the CLI and let's go to privilege mode. And if we want to look at the FHRP address for VLAN 20, let's just show standby because that's what I'm running. It's the hot standby router protocol for FHRP services. And what this is saying is for VLAN 20, meaning I configured HSRP on the VLAN 20 interface, the virtual IP address is 19. And so that's what I want to put in my documentation because that's the IP address I chose. And let's go back and make sure that we got that right. Yeah, okay. Well, I didn't put it in yet because I was curious. So .19 is the FHRP virtual IP address on VLAN 20. So if we have DHCP services, which I do in this lab, we'd have two pools of addresses, one that's appropriate for VLAN 10, one that's appropriate for VLAN 20. We'd also, when we're handing out a default gateway, we'd go ahead and hand out the default gateway of the FHRP address, the .4 or the .19, just like that. All right, super. All right, moving on. So R1 is not in VLAN 20. The server isn't either. These access layer switches are supporting VLAN 20 at layer 2, but they don't have a management IP address in those networks. And R2 and R3 are remotes. Great. Next, we know our next subnet is 32. 10.67.83.32. We took the block size and just added it. And now, let's take a look at VLAN 7. So for this management VLAN, all we need is 6 addresses. So we could use a /28, but we would be wasting address space for hosts that we might need somewhere else. So let's do this. Let's calculate how many host bits we need to leave if we want to support about 6 hosts. All right. So it's a finger game. How many host bits do we need to leave? And the game goes something like this. That's not enough. That's 2. That's 4. That's not enough. 8. Okay. We need to leave 3 host bits for that management network to support 6 IP addresses. 2, 4, 8, minus 2 would be 6. That's it. So we need to use 3 bits. That means for this next subnet, the mask can go all the way up until the point where it matches, until it leaves 3 bits for host addressing. So let's do that with our next available subnet. So here, the 10.67.83.32 network / and let's go down here and do some magic with what mask we're going to use here. So I'm going to erase some of this. Just like that. All right. Bring back my pencil. So we agreed that we need to leave 3 bits. So what that would look like is we're going to leave this bit, and this bit. 2, 4, 8, minus 2, 6. Great, because we need 6 IP addresses. And then that will be the new dividing line. And then the mask would be all ons in this 4th octet. And so our new mask would be, start here at 24, and then just keep adding 25, 26, 27, 28, 29. That would be a /29. Based on our high-end math that we just did. And the next subnet, because the block size is now 8, the next subnet would be 32 plus 8, which would be .40. 32 plus 8 more. That's our next, so we can calculate the range easier. So the range for this subnet, we'll call this our management network. The range for this subnet is going to be .33, the first IP address, and then 2 below the next subnet, which would be through .38. 33, 34, 35, 36, 37, 38. Those are the 6 valid options that we have for host addressing on that management network. And then we can decide on how to assign those. So for the management network, this is going to be subnet 32/29. And for the multilayer switch, let's give it the first IP address of .33. For multilayer switch 2, let's give it the second IP address of .34. And the first hop redundancy routing protocol is just a that doesn't, we're not giving it any IP address on the management VLAN. And for R1, see, good documentation is really important. I would assume that I don't know. Let's go take a look and see what IP address I assigned for the VLAN 7 interface on router 1, and that will also help us clarify what we did for switch 1 and switch 2, the access layer switches. So let me hide that layer for a moment. Let's go back to Packet Tracer. And one of the cool things about Packet Tracer is this. I mean, this is really cool. We can just hover over a router. Let's go ahead and hover over R1. Look at this. So it shows right here that the VLAN the VLAN 7 interface is 1067.83.37. So this would be .37 on that VLAN 7. And the access layer switches, if I hover over them, this is showing us that its VLAN 7 is 35. Okay, access layer switch 2 is 36. And okay, so I put the access layer switches first with their IP addresses in that management VLAN, and followed by R1. So let's go update our documentation. I'm so glad I looked at this and had this live, didn't have to guess. And this is the kind of practice that's really helpful too. You can build this lab and just go put those addresses in, and if you document as you go, you'll save time as well. So this is going to be access layer switch had .35, access 2 had .36, and R1 had .37. And none of the other devices here on the table had IP addresses in that management VLAN. All right, then for VLAN 30, this is the VLAN right here that the only people connected to that are the multilayer switches and router 1. So all we need is 3 addresses. Our network we already know is going to be 10.67.83.40. Now the question is, if we only need 3 addresses, how many host bits do we need to leave? This is a great game that keeps on giving. So how many host addresses, or how many host bits do we need to leave available for host addressing to support 3 devices? Let's go ahead and put our thumbs up. 2, that's not enough. 4, but you have to do the -2. So if we use 2 bits, that gives us actually only 2 possible host addresses, which is enough. So we're going to have to use 3 host bits, just like we did on the previous network, to make that fly as I look at my notes. Yeah. So we're going to have to use, just like the previous subnet, we're going to have to use a /29, which is going to leave 3 host bits, which is going to give us enough IP addressing to support the 3 hosts that we need. So there's a little extra in that VLAN for host addressing, but 2 bits isn't going to be enough. We need to leave 3 host bits. So let's do it. So we'll go ahead and we're going to use the same mask, /29. And that way we can also identify what the next subnet's going to be by adding the block size again. That doesn't change. The next subnet's going to be 48. And that means our range here is .41 through .46. And that's our 6 valid IP host addresses in that 10.67.83.40 network. Yep. Okay, so let's plan out the assignments here on VLAN 30. Multilayer switch 1. So this is the 40 network with a 29-bit mask again. So multilayer switch 1, I'm going to give them the first address, which is .41. I'm going to give multilayer switch 2 for VLAN 30, the second address, which is .42. And for R1, let's give them the third address of .43. And then all the rest are not involved in that little VLAN. So we should verify this too, because I'm documenting as I go. This is for my benefit too. I thought, let's do a rehearsal of doing variable length subnet masking within a block of addresses and getting hands-on practice with Packet Tracer. But it's also helping me because when Network Chuck, when he implements problems in this network for me, which he's going to do, I think, next week, it's going to be handy for me to have really good documentation of which IP addresses are on which subnets. That way I can easily identify, oh, that's the wrong IP address for that subnet. That's not why it's working. Or whatever problem he happens to put in. He hasn't told me and is not going to tell me. what he's going to inject. It could be layer 2 problems, layer 3 problems, a combination of those, routing, layer 2 switching, trunking, whatever. Bring it on. I'm looking forward to it. All right, so what we want to do here is I want to verify the IP addresses on VLAN 30 before we move forward. I'll make sure I have it right in the topology. So back to packet tracer we go, and all we need to do is we could hover over these devices and just take a look at the VLAN 30 interface. So router 1 is .43. Multilayer switch 1 on VLAN 30 is 41. Yes, 41, 42, and 43. That's what I chose to do. And the cool thing about Packet Tracer is you can download this lab and you can take your time. You can just enjoy it, practice with it, verify addresses, and have a good time doing it. There's no rush. Let me bring back my notes here. Yeah, okay, so .41, .42, and .43. And then for the wide area network, I still need 3 hosts. So I'm going to have to still leave that many bits, 2, 4, 8. Yeah, I'm still going to have to leave 3 bits for host addressing. So this network, the 48 network, is also going to be a /29. The next subnet is 48 plus 8. That's going to be 56. 8 and 8 is 16, carry the 1. As I look at my notes. Yeah, it didn't feel right for some reason, but that's the right. You add the block size, away you go. So the next subnet's that, and that's going to help us identify the range. So the range for this subnet, the 48 network, is going to be .49 through 54. And then I could apply those addresses to the WAN interface sides of the routers, router 1, 2, and 3. So I could put those here. In fact, what I might do is, because I have this whole range for that wide area network, let's do this. For router 1, let's use .51, just because router 1, 51, and for router 2, let's use .52, and for router 3, use .53. And you know why we can do that? 2 reasons, really. One, it's our network. We made it in Packet Tracer. We're making the rules. We're designing it. And also because it's in the range. We can use any of those IP addresses in this range for that network. And so we can just go ahead and choose what we want to use. And then that's actually what I from the previous look at those routers, that's the IP addresses that they have. .51 was on this interface here on R1. Okay, so this was an exercise in taking a block of addresses and actually carving it up with variable length subnet masking based on the requirements and then implementing it. So in Packet Tracer, I would encourage you to do a couple things in Packet. Also, the other 2 networks, if you want for bonus points, the other 2 networks, let me take a look and see what our requirements are there. I finally documented my work here. All right, so at site 1, and this is, I'm going to say this is homework, and I would encourage you, if you want to practice your subnetting, go ahead and take this call to action, plan it out, and then implement it in Packet Tracer. Just drag some routers up, configure the interfaces, configure a client or 2. So for site 1, we have 2 VLANs that we need. And a VLAN is a layer 2 construct, and usually there's a layer 3 logical network associated with that layer 2 VLAN. So if I say 2 VLANs, it's going to need 2 subnets. And let's use the block of addresses 10.67.83.64/26. Now you'll notice that these addresses at headquarter site, they stop before I get to 64. That's because if you look at the block size for a /26, it doesn't go into that 64 range. So I'm reserving 10.67.83.64 to /26 for site 1, and for site 2, I also need 2 VLANs, and we're using 10.67.83.128/26. And again, based on the block size, site 1's address space is going to end before we get to site 2's address space at .128 with that mask. And what we need there, let's see if I can simplify this. Oh, yeah. These 2 VLANs, they need 30 hosts each. So carve out 2 VLANs out of this space. They both need a host addressing supports 30. So I would do this. Let's say I need 30 hosts. How many bits is that going to take at the far end of the IP address to do that? 2, 4, 8, 16, 32 minus 2. That's 30. Great. 5 host bits. So basically for both those solutions, for site 1 and site 2, we need to leave 5 host bits for host addressing. And then based on what that new mask is and carry it forward, you could plan that out and then just implement it. So that's my request for my call to action, if you're up for it, is to actually do that calculation for Site 1 and Site 2 and have a good time doing it and then lab it up and practice it. So let me finish off this discussion by bringing up the topology once more and reminding you of where you can go ahead and get it. This is the topology I built. There's a couple of really fun things that are happening with this. And one is this. And I saw this, I thought, oh, I'm going to have to explain that. Maybe I shouldn't, but I'm going to. In this topology, look at all these icons here. See how on these scooches over a little bit, center a little bit. Doink. Where are we going? Oh, I see. Hold on a second. Let me, give me a second to dial this in. It'll be worth it. And then I'll just bring it up a little bit and scooch it over here. All right, great. Now this don't line up anymore. All right, here we go. All right, thanks for that. Thanks for letting me line that up for us. So in this topology here, look at these LED indicators, and you can turn them on and off. You can go up to options and preferences and turn on the LED indicators, turn them off, show the port information, don't show the port information, show the model information, just tons of options. You can make it bigger and smaller, lots of fun. But see how all these LEDs are green? These are all switch connections. Everything coming off of MLS 1 and 2 are switched. They're trunks. And everything green implies, well, maybe spanning tree isn't blocking anywhere. See, spanning tree is blocking right here. Look at that. Spanning tree is in a discarding state if it's rapid spanning tree, or a blocking state if it's traditional spanning tree, or if you're running either one of those, it'll still show as blocking. Anyway, it's blocking here, but it's not blocking anywhere here. There's definitely loops here. What's going on? And this reality check here is the fact that it's not packet tracer messing up. It's that I am doing load balancing where I'm having one multi-layer switch be the route for some VLANs, and I'm having a second multi-layer switch being the route for other VLANs. And so what color do you do a link indicator if it's blocking for one VLAN but forwarding for another? And what packet tracer decided to do was, well, if it's forwarding for any VLAN, we're going to go ahead and give it a green. However, to find out what's really going on here, we would use our spanning tree techniques. Show spanning tree for VLAN 10, show spanning tree for VLAN 20, identify where we're, who's the designated switch, who's the root switch, which ports are designated, and that's why none of these LEDs right here are amber or orange, whatever color you want to call it. It's because I'm doing some load balancing with spanning tree, which we've covered in a previous video as well. So that is that's in the playlist. So to summarize, and I give myself a quick chuckle because when I talk about summarize, we've also taken a look at route summarization in our Subnet Saturdays. Let me share with you one more time where you can get this file. So this site is called thekeithbarker.com. I will also add it as a description in the link, or a link in the description. So thekeithbarker.com, if you scroll down, among other things, there's options to download a few of these packet tracer files that we've been working with. And this one right here is Cisco PT IPv4 subnets. It is my fully functioning lab that I built on Monday in preparation for Network Chuck to implement some problems in it. And then I'll go ahead and record later the walkthrough and the solution for that. But if you want to see this has exactly the IP addresses that we talked about. And also, if you want, this is fun to do. You could take any one of those devices. Like, let's go to an access layer switch. So you bring up an access layer switch, or any device that has an IP address. It has an IP address just for management. That way we can manage it remotely. We do a show IP interface brief. Even though this is not a router, it's got a management address in VLAN 7. So what we could do is take that IP address and say, all right, based on this IP address and the mask. So if we go into privilege mode, you can just show run and take a look at the interface VLAN 7. You can say, based on this IP address and this mask, what subnet is this guy in? Now, we've had a video in the playlist for Subnet Saturdays where I walked you through how to reverse engineer this information, where it's like, okay, based on this IP address and that mask, what is the subnet ID? What subnet is this client, this device connected to? Which is what is the management network that this client is connected to? So that's another exercise that you could do to help practice and review your subnetting skills. And once you do this a few times, at the beginning it's not easy. It's not as like, oh, in second nature. But as you practice it more and you've gone through every single one of the Subnet Saturdays streams that we've had, you'll get better and better. And then when you rehearse it like this, it's going to help cement that information in. And it's not just good for certification. It's also good for the real world when you're working with devices and you're troubleshooting, like, why isn't this guy talking to the rest of the network? Knowing those subnetting skills is going to be really important. So you can download this packet tracer file here at thekeithbarker.com. And the other thing I would encourage you to do is, this is let me go back to my, So there's our site. Hey, Mr. Sloth. Okay, so also why Mr. Sloth? Why is that my spirit animal? There's some humor behind the scenes, but one of the things I like you to think of when you think of a sloth, and by the way, that's the URL for the master playlist, is OGIT, the original gangster of IT, .online/sloth. And the secret to the sloth is that it's pretty cute, and that's cool too. But the secret is that the sloth is consistent. It may not be like the tortoise and the hare, like the rabbit, run, and the tortoise is slow and consistent and methodical. If a person moves like a sloth in their studies, check this out. If they're in their studies and they're just consistent in their studies and moving forward as they go, consistency, enjoying the process like a sloth, you're going to be way ahead of somebody who does fits and starts and stops and gives up on things. Just be a little bit more consistent like a sloth, and you can tackle anything. And I would start with CCNA. If you're new to networking, or if you've been in networking for a little while, get the CCNA, great foundation of information, and then you can proceed with whatever you want to do after that, which is the professional level for Cisco, or maybe CCAE for Cisco, or other vendors' technologies as well. And there's lots of different resources that a person can use. A lot of them are free. And also, many of you know I work at CBT Nuggets. This is my full-time gig, and we make content there. And for CCNA, it's Chuck Keith, Network Chuck, Jeremy Char, and myself that created 52 hours plus. It's a paid service. It's not free. But if you want to check it out, you can get a free 7-day trial and give it a whirl. And it has labs built in with it as well. But there's lots of really great free resources here on YouTube and other places, and also great books. So it doesn't matter to me what option you use to learn the skills and get really, really great at it, but I would definitely love you to do that. And I think that our streams and our content can really help with that. So on the Keith Barker page here, if you go to videos, well, if you click on the home page for Keith Barker, hey, Mr. Sloth. There's Mr. Sloth again. I put near the top these playlists, the master playlist, and then the playlist for Subnet Saturdays, which includes this video here, and also the security for CCNA with security-specific topics like dynamic ARP inspection, port security, DHCP snooping, and more. Also, I wanted to, as we close off this session, I wanted to share with you how I've tweaked a little bit to adapt to the times. We are living, it is March 21st, 2020. We are in some very different times with with the pandemic and with coronavirus and all that. People being sequestered and quarantined, and I live in Las Vegas. It is closed. Vegas is closed. The governor a few days ago said every non-essential business, you need to close your doors. So most of the big hotels are closed. Streets are empty. It's really, really strange. In any event, where was I going with all that? Oh. So I have live stream schedules for 3 a week. Wednesdays at 4 p.m. Pacific, and then Saturday and Sunday at 11 a.m. Pacific time. And what I discovered as I've done the live stream since this change, where it feels like the whole world is working from home or attempting to, and then people are streaming content all over the place, Netflix, Hulu, Disney Plus, etc. Plus they're working from home, VPNing, conference calls. There's been a incredible strain on the internet. And so I had a stream that I did, and it broke. It was 23 minutes in, and it just and would not connect. And at this home office I have here, it's got really high-speed internet, but if there's so much demand, the internet's a big place, I get it. So what I'm doing for a while, including this live stream, I'm live streaming this to zero. I'm live streaming this, basically recording it locally, and then I'm going to upload it, and that way it can all be there. So I'm recording it as if you're sitting here right now watching it with me and enjoying it, which is great. Good to have you. But I thought for the time being, I'm going to record it local, no edits, just all the way through. And Judd just joined. Awesome. I have the ticker on, so even though I'm not really live right now, I'm recording this, I still have that alert message on showing people that are joining. So thank you for joining. Okay, so I was getting back. So I'm going to record still my 3 streams a week, but I'm going to record them like this and then upload them without any edits. So that way you get the live experience. Whatever comes up, whatever shows up is going to happen, just like it has when we were doing them live. And then I'll still open the doors for a live Q&A. So we'll do some live streams, but it won't be as critical if they blow up or if they can't continue or if there's hiccups in that stream, because it'll just be Q&A for me chatting with you about the topics in CCNA, sort of like instructor hours. And that way we can all win. We can have the content on the site, in the playlist, uninterrupted, and at the same time we can still do some Q&A. So it is local time. I'll give you a little inside scoop. It is Saturday, so this is a Subnet Saturday session. It is 9:50 a.m. So I started at 9. I just basically said I'm going to pretend my live stream is starting at 9. And I put my plans together last night and this morning, what I was going to talk about. Then at 9 o'clock, I put the countdown timer on right before 9, hit record, and said, here we go. We're going to do this live. And I realized that you may be watching this after the fact, and that's totally cool. I'm glad that you are here. And then when we finish in about 2 to 3 minutes here, when I click on goodbye, I'm going to do a live stream at 11 a.m. Pacific, just like I normally would, where it's just going to focus on the Q&A and the chat without the content. And that way, if we lose some content, if the stream breaks or if the internet can't handle the load, whatever it is, we can jump back into that stream and we can still do the Q&A, but it won't mess with your content, because I know content is king, and I want to make sure you have access to all of this content if you want to watch. So 3 things I'd like to leave you with. Number 1, hang in there. Number 2, learning technology and getting better all the time is totally worth it. You increase your value to yourself, your family, your employer, and your quality of life will improve as you improve your skills. And then 3rd, if you are new to IT, if you're new to the world of Cisco, I would encourage you to carve out chunks of time and just start with the Keith Barker playlist, the CCNA playlist on YouTube, and just start going down it in order. And as you address each one of those, your skills are going to grow. I'm going to encourage you, as I am in this video, to continue to practice with Packet Tracer, which is free from Net Academy, and have a lot of fun doing it. So I'm going to close off this stream for the moment, and it's been great having you. If you haven't already done so, please click on subscribe, click on the alert bell, let your friends know if you're studying with them about CCNA or Intro to Networking. We'd love to have you here. We have a Discord server as well. The link is in the description. It's growing by the day. We've got about 10 or 12 fantastic moderators who are just volunteering their time to help you in learning your skills and focusing on getting your CCNA and above. So thanks again, everybody, and I'll see you, my friends, in the very next video. Bye for now.